We're going to be Today we will be hearing from Scotty Strachan. He is going to be talking about his SCIPE award. I love the name of it, the Wild West. I can't wait to hear more about it. With that, I'm going to turn it over to Scotty and then we'll have questions after. Thank you.
Okay, thanks, Betsy. Yeah, so good morning Pacific time, everyone. I guess good afternoon for those of you on the other side of the country or in the future. Um, yeah, the working group here asked me to come in and talk a little bit about our workforce development project that's called the Wild West. And this is a project that is definitely square inside of the whole cyber infrastructure research technology community, but it really involves a different set of subject matter expertise, technologies, and emphasis from kind of traditional research computing. And what I'm hoping is that this presentation spurs us to think about what are the ways in which we need to be building new professional workforce capacity across the broad range of technology as we know it today. Research computing's come a very long way, and we're in a very different world now than we were 20 years ago. And so while I'm going to talk about kind of the field science and the wild area networks and wireless and all that sort of thing, I think there are a lot of other opportunities in other technology niches that we as a community could start to develop more professionals in. So that's really my take home. You can, log off and go to lunch now, I guess, if you want. But with that, I'll just go ahead and get started. So in this talk, some of the concepts that you'll hear emerge, I've never given this particular slide deck before, so this is going to be very ad hoc. This is about meeting scientists where they are today, so evolving our concept of research IT. The areas that we work in this project across a wide variety of physical data and social networks, as well as projects and people. So we're not just addressing like a niche. I mean, we really are in this project hitting a wide variety. We have very different subject matter expertise, as I alluded to before, including things like power systems, wireless, and data flows. There are a bunch of new tools that scientists can or would like to use in this space, including modern virtual private network technology, low Earth orbit satellites, off-grid designs, long-range wide area networks, and of course, more software. This means it's a complex ecosystem that we're beginning to address. In this project, our objective was really to create new boundary-spanning research IT roles, as I explained. And one of the things I'm hoping that we can discuss at the end of this deck is the pitfalls and possibilities around new CI professional projects. I'm not going to spend a lot of time here about me. I have a PhD in geography. That doesn't necessarily tell you what I'm good at. Basically, I'm a mountain climate scientist. I had to build my own technology to get that done. I am a PI or co-PI of a bunch of different projects. I work at the regional network and regional higher education system in Nevada, so I'm no longer at the university. I've been in this space for about 4 years now, and I'll talk a little bit about regional networks here in a second. NevadaNet, where I'm at now, is part of the Nevada System of Higher Education. We're in the System IT organization. We have data center buildings in both Reno and Las Vegas. We have 2 R1 universities, a bunch of state and community colleges, and a research institute. We are kind of a full stack IT shop. So my group, research engineering, that I started when I came up to system, we fit right in because we touch everything from hardware all the way to kind of the end products. And so it was a good place to start this workforce development concept. Like I said, we're kind of at the system level in our region. This is something that for Nevada is kind of nice because we only have one system. I know many states have more than one system. It can make things complicated. In our case, we only have one. So that means that I get to wear, even though I'm wearing a UNR hat right now, I can wear a neutral hat when I go in and talk to my colleagues at the different institutions, and it's not quite as political. NevadaNet is also the research and education network. So besides having kind of that full stack shared services IT, We also run the regional optical WAN, and we connect many different community anchor institutions, K-12s, et cetera, to this network, as well as the higher ed. So that's the background in terms of where I'm coming from when I say I'm doing research engineering regionally. We are part of an ecosystem that involves both the Internet 2 and many other dozens of other RENs that are traditionally higher ed affiliated, thanks to the 1980s, 1990s evolution of the NSF net. This is the network as it exists today for research and education. And so no matter what state or region you're coming in from, there is somebody in your area that does something similar in terms of the optical WAN. And many of these organizations already do research engagement or are getting more involved in that moving forward. So when you think about regional CI pros, think about who your REN is and think about working with them. So there's a lot of geography between all those different network nodes in that map. Doesn't science happen everywhere? So I'll go back really quick, right? We see a lot of white dots where there are cities and institutions. But science happens generally across this landscape. And in fact, where I'm at in the West, it's especially true. So if we go to my home watershed, there's a lot going on in this space, a lot of conflicting stakeholders, a lot of different trajectories for both human development and the ecosystem. And we would like to think that we use science to address a lot of the decisions that are made around resource use, conservation, and disaster mitigation. So National Science Foundation funds a lot of work in this space. But again, these are all silos unless you have teams that bring them together through some kind of lens. That lens can be technology. When I speak with my colleagues, so in this case, I've got a colleague at the Desert Research Institute, Dr. Ann Hegley. She's a scientist that does decision-making tool development for water resources, but she has a background in sensor development and electronics, and then she brings that to bear on her science. And so getting inside the head of where your scientists are, like what their background is, what they want to accomplish, what their goals are, what they want their science to be, very important when you start picking out like what are the CI professional roles that you want to develop. So what I've looked at in Nevada and I've really kind of settled on as one good lens to move forward and bringing a lot of these different science pieces together is kind of this Internet of Things, or I like to also say the Internet of Wild Things. Sensor technologies is really revolutionizing environmental science at scale. There's a lot of benefits to this. There are also some risks. So risks include things like perception of accuracy, device before management, i.e. graduate students buy stuff and they go out and develop it, deploy it, and they don't necessarily know like what are the modes of error? How does this thing compare to, previous observational methods, et cetera? And then, of course, when everything is direct to digital, there's always a danger that it becomes vaporware. So, I did come from an era of taking your observations kind of by hand. I'm still sometimes in that space, but not always. But I can always go back to my notebook unless the lab burns down. So thinking about the long-term resiliency of the digital piece is very important. I also like to approach the science from this concept that you need to work to develop the best possible data. Let the data lead you to hypotheses about cause and effect relationships. So that means I'm on a mission to help scientists gather as much direct observational data as possible and make that widely available. So that's kind of like the core thinking behind what WildWEST is designed to enable in the science space. I actually pulled this XKCD comic before the AI revolution really took off, but it's still very relevant today. One of the dangers for environmental science or observational science is that it turns out if you only collect, if it's very difficult to collect, if it's very expensive, you can only do a little bit at a time or in only one place. There's always the temptation to do lots of data generation to make your data sets larger. And so that's something that we want to avoid. We want to really say AI is great. We should be using that in data science and analytics. We need to figure out how to deploy 100 or 1000x more sensors and get a lot more observations out there. So what are the key supporting technologies in this space? Power generation, storage, and distribution is one. Digital communications are another. IP networks, and software infrastructure. So these are the areas in which our project is aimed at. We view environmental science about is about this end-to-end workflow across a variety of scales. So there's kind of this um, scale on top where we go, kind of from 1 kilometer to 10 kilometers, that's the edge, all the way to continental and global scales, 1,000 kilometers. And there are different parts of cyber infrastructure along the way. And this community has actually been very good about developing cyber infrastructure at global, national, regional, and campus scale. But where we really have a lot of space to do some more work is kind of at the edge and in the community Internet of Wild Things. So, what are the science domains that we're talking about here, and what are they trying to observe? So, getting back into the researcher's head. So, this is a shot from one of my projects. This is actually a fire science project that I am a co-PI on at state scale. There are several different institutions and departments just represented in this picture alone. They're all taking different kinds of data around a field experiment, and there are some drones in the air that you can't see either. That makes for a complex landscape, and so getting an idea for what these people want to do and what technologies they intend to deploy is something for the research IT community to consider. I mean, we're not just about working in the data center anymore. So more often we see science is mobile. The technology is mobile. It's a great place for us to sink our teeth into. Also, what if it's widely distributed? So if we want to know something about, for example, snow distribution in different watersheds, that's a lot of landscape to go attack, and you can't necessarily get all the information that you want from satellites, and we also can't afford terrestrial aircraft flying over every hour. So we have to address that with sensors on the ground. What about things like data latency? So here's one of my colleagues in one of my projects. They've got a scanning LiDAR on a truck that basically images smoke plumes from wildfires and other aerosol sources. And they have to do things like deploy weather balloons with SONs, and those SONs need to transmit data to the managers of the experiment. How do they do that? They need networks and they need real-time data latency in order to do that. Or what if there's a specialized integration? So in this case, we'll see a little bit later a couple shots from the Summit Lake Tribe watershed where they have a fishery conservation long-term multi-decadal fishery conservation project for the Lahontan cutthroat trout. Now they're starting to embed these RFID devices in the fish themselves, and the fish swim through antennas. Those antennas log the passage, and then we have to transmit that data out from the middle of nowhere so that people can see in real time what's going on with the watershed and where the fish are. So that means extending the research network off campus. And sometimes that can be a very long way. So there's a long-term climate monitoring station that I maintain up in the High Sierra of the Walker Basin in Western Nevada, Eastern California. And there are 4 hops to get back to campus, some of which are quite long, to keep this station alive and running and transmit the data. The tools that we use are also very different than your typical cyber infrastructure tools that we're used to. In fact, kind of here's a layout in the middle of a project build. It looks more like a construction site than it does a computing organization, but nevertheless, that's where we are. So the overview of our project is a collection of colleagues from Utah, Arizona, and Nevada. And it's actually the 3 research and education networks that came together to solve some of these problems and develop more capacity in this space. And so my co-PIs include Jim Stewart, who's retired now, but was the CTO of the Utah Education Telehealth Network. Joe Breen, who is at the University of Utah in the CHPC program. And Derek Masseth, who is the executive director of the Arizona Sun Corridor Network, based in ASU, but serves the entire state. And so our intention was to really facilitate the last 100 miles of technology for science, develop new roles of research IT professionals in our organizations to do that, and then start addressing the best practices and gaps in these spaces for both the regional and national communities. We expect that we will create new regional science partnerships, both between our states and between the stakeholders that we serve, in areas like wildfire, water, snow, smart agriculture, and other science fields. So our approach is to hire, which we've done, one FTE, one full FTE in each of the organizations, plus student trainees. So this is three FTE total plus students. Um, Again, it's based in the research and education networks, not on individual campuses. So that's a twist on what the mission is and the fact that we are already regionally engaged. We are focusing on the skills training in these areas that I've already mentioned. And we also want to establish multi-state science field stations as our test bed for rolling out and developing different technology solutions for science in our areas. We expect to deliver new personas of science users to the national research computing community. And we want to make sure that we get those people into the IT contributor and IT facilitation ecosystem. So these are terms, if you're familiar with the CSSN and Access, those terms should be somewhat familiar. We also identified core science collaborators that were willing to work with us on being, test monkeys, helping us help them, allowing us to try out new technologies and bring new people into the space, so that we had active science projects that we could already sink our teeth into. So we intend to be very community engaged in terms of regional skills training workshops, rural community and observational science focus to build trust with our rural communities in our states. We want to boost the research and education regional network mission as research IT support organizations. And we want to do this professional development also through the NSF communities like this one. And we are doing our technical practices dissemination in concert with colleagues in various agencies and organizations to include USGS, Department of Energy, ESNet, and Internet 2. The project is structured as follows. It's split in an even manner 3 ways. So while I'm the lead at Nevada, I do not have a bulk of the resources. In fact, my overhead rate was better than the overhead rate that we negotiated with the other organizations. So I think my budget's slightly smaller than the other two. But nevertheless, we are equal partners in establishing these roles, and we each have our own scientists that we're bringing in and field sites that we're bringing in. We are engaged also beyond our region into the Access and CSSN community right now through the NEAR pilot program as things have been retooled. We'll talk about that later. As well as the Earth Science Information Partners, the Quill, Internet 2, and CaRCC, this organization right here. So our timeline looks like this. Many of you who have done hires in the last few years can probably identify with the fact that it took us 6 to, in one case, 12 months longer to hire than we had originally thought. By the time awards were set up and administrative workflows were established. So in the realistic timeline, we're going to take all these years and just shift them by 1. So we called year 1 year 0 in our last annual report because it really did take a long time to get everybody up and running. But basically, there's a progression of milestones that we have in this project that we want to walk through. And right now, I would say we're right in the middle of that integration with the national communities and balancing the internal and external work cadences of our hires. So our project is also broken out by these different phases of spin up, workflow balance, assessing functional impacts in the scale that we'll be able to address, setting our long-term trajectory for these roles, and moving into steady state operations and adoption of these roles by the home organizations by the end of the project. So we can always come back to this if you want later. There's a lot going on. But we basically have, across those phases, field cyber infrastructure service and knowledge, consulting and training, and community development activities. So the first step was to hire some awesome people. And this is, we were very fortunate to find 3 experts in different fields that fit well into the objectives of the project and the kind of interaction with scientists and the national community that we wanted to see. And so we've got a very, actually quite the difference in backgrounds here. We have a recent ecology grad in Nevada. We have an enterprise IT and business grad with Air Force experience in Utah. And then we have a full-on mid-career PhD in Arizona who is a PI in her own right and has spent a lot of time in the LTER, long-term ecological research network space. And so this is a great variety to have on the team, and each of them bring different strengths and experience to what we're up to. So year zero really was creating these new professional job descriptions, starting the hiring and searches at the RENs, also getting the RENs used to grants participation in a couple of cases, as funded by the National Science Foundation, settling on project management and coordination, getting our administrative multi-state workflow coordination down, doing surveys and assessments with our core science partners, starting to do the design and installation engagements to sink our teeth into the topic, doing a bunch of equipment acquisition and training for the professionals, and coming together in our annual all-hands summer camp workshop. So one of the key parts of bringing the team together here was, let's create an environment where people are enjoying what they're doing. It's outside of their normal routine, and it puts people together in a space where they really get to know one another through shared experience. So I don't know about you, but when I was a kid, I did go to summer camp a couple times. So we envisioned this as like summer science camp or science and technology camp. And we had one, as we were kind of in the proposal writing phase. We had another one soon after right after the award was made. And then we had a third as our final professional was being hired. And actually, she was not able to attend in person, but she did come in on Zoom for some of the activities. And we're really looking forward to this August when we have our first summer camp where it's everyone together. We've all been working together for almost a year, and we've got a lot to discuss. So Hat Ranch is a historic field station / hospitality ranch owned by the Northern Arizona University. It used to be an Arabian horse raising ranch, and it looks like this. And our agenda for our summer camp was a welcome, project overview and status. We brought in stakeholders from all of the sciences that are in our core from our states. We also had a number of external agency personnel from DOE, from USGS, from a couple of the national labs. So we had a good variety of stakeholders come in, and we had them do a presentation session. We then went through what are the science requirements that we have in our core projects, and then mapped our capabilities across the team. We then did some learning and demonstrations on specific technologies that we want our folks to get familiar with or train others in. And then we did some hands-on Hat Ranch field station network mapping and planning. And then we did some planning sessions at the end and wrapped it all up. So really like bringing together people for 4 days. There was a lot packed into the schedule, but it was a really effective time. And I would highly recommend that anyone building a team that's distributed across geography, think hard about how you bring people together and how you really let them mesh as a team. So I'm just going to throw some slides up here. So this is one of the scientists presenting their problems. This is one of the guest industry engineers giving us a clinic on RF spectrum monitoring, and then flying the spectrum analyzer and the wireless connection to that on a drone and transmitting the spectrum data back in real time. The students and the professionals got to do some hands-on training together. So we brought some students and staff together, gave them some problems to solve, and they went and had a great time learning how to use some new tools and techniques. even installing some science gear out on the field station. And of course, in the field, food is motivation. As a very long time field scientist, I will tell you that, as long as you can keep people fed, they stay happy. Everybody pitched in. The ranch house has a great kitchen, and we had a really good time in the social hours around meals, which allowed people to get together and also talk about what are the different projects that they're working on and what's going on back at their home institution. So by the end of the summer camp, I think everybody had really like come together as a team. They understood what was going on. They were ready to engage regional science projects. So as an example, now this is not all the projects that we touch. I'm going to run through just a couple of examples. So this is a project that has NSF funding in the Lake Tahoe Basin, but they really needed some help in the wireless network design space. And so we worked with them to start a LoRaWAN sensor pilot. And there was a bunch of computer scientists and engineers along with the state climate office that were really the PIs of that project. As part of the spin up of the WildWEST, the Utah BLM fire camera project really kicked off as well. So we were in Nevada, we have a pretty mature fire camera network. And so we were able to help Utah get that started with the BLM and make sure that it was based in the university where the data would be used by a number of different scientists. So this is what towers look like after the winter or early spring weather goes through. Everything gets turned into a popsicle. The long-term monitoring network in Eastern Nevada called NevCan, which is where Ann Hegley, that scientist from DRI, is located. This is one of her main study sites. So we went out and started doing some work with her on NevCan. The Bonnerman Rio Mesa field station needs a complete network ground-up design. So it's a great opportunity for the team to do that, and we're engaging with that one. And in Nevada, we have this Seismolab regional network that does both earthquakes and fire cameras. And this team has been working in the field for a long time, and they have a lot of really good tips and tricks to teach the students and to teach the new professionals. And so we engage with them. And then kind of the flagship project that we even got some science data products out on the web for this year was the Summit Lake Tribe watershed that I mentioned earlier, where they have a fishery and they have a few other cool ecology projects going on. And we have end-to-end demonstrations happening on that project. So the next step really is to develop our roles inside the national science community, which includes CARC, includes an air pilot, and includes the Earth Science Information Partners and other organizations. The student mentoring role is something that we cannot lose sight of. Like the students are really the next generation of people who will be doing this. And so we've been making sure to put effort into lab exchanges where we've had students from Utah come to Nevada, work in the lab, get trained on both some of the software as well as the field deployment techniques. We've also gotten students lined up with undergraduate research opportunities that we can support from this project to give them some ownership over a research engagement. We do weekly regional team coordination calls, both for the PIs and the engineers. And we are establishing our engineers' roles and facilities, like their own labs, inside of these home organizations. We are also starting to kick out some best practices creation and publication. So we've got a paper actually on the Summit Lake watershed in PERC this year. So what I was hoping that the community might want to discuss here are challenges related to developing regional professional roles and programs. And so for one, right now we're dealing with a lot of NSF chaos. Is this the part where we keep the recording going? I think so. I'll be careful. There's a lot going on in NSF right now, and a lot is changing in terms of the cyber infrastructure programs. We've heard that from program directors in public settings, so this is not news to anybody. The access and CSSN model, which really evolved from way back when in the TerraGrid days, it seems a bit frozen to me. And it's not clear to me how people who are not HPC engineers will be able to engage in the, kind of post-access in world. And what I'm hoping is that when we get to the, like for example, the NAIR OC award, that maybe that'll start to unlock, and we'll see like, okay, what are ways in which these broader ranges of subject matter experts can really dive in and help scientists. Um, we have to keep our subject matter experts motivated. So when we hire people to do specific things, we need to make sure that they're still doing those specific things and they're developing themselves and their techniques in that space. I think there's a lot of cool concepts in terms of science engagement that this community has developed. We need to make sure our SMEs are getting embedded in that and they understand they're part of that community. But again, the technical scope is very, very different. We want to make sure that these kinds of workforce development projects are adding value to the science community. So we need to be thinking about like, what is our measurement of impact? And how do we know that what we're doing is truly moving the science forward in ways, in our case, at scale? So hopefully NSF will calm down and we can address these effective models of science community engagement moving forward. There are also some other challenges. When you have many different organizations involved as collaborators, sometimes something goes wrong in one of those orgs that you have no visibility or control over. And so, for example, last year, the University of Utah IT organization from the very top, Steve Hess, retired, and there was this big reorganization that happened. And that affected CHPC. It affected the Utah Education and Telehealth Network. And it also meant that for my project, my co-PI there retired early. Fortunately, my other co-PI, Joe Breen, is still there at CHPC. But in UEN, they really they had to come back and decide like how do they want to engage these kinds of projects. And it was very chaotic and it was very difficult for me as an outsider to deal with those unforeseen and abrupt changes that happened across the organization. Our hire, Alex, actually got absorbed into the core UEN staff. So he was taken off of the NSF project for political reasons and put into the core enterprise at UEN. He still comes to our weekly meetings and he still contributes material and information, but we're not paying his salary anymore and he doesn't have an obligation to do stuff that isn't on the UEN network. So that's a challenge. The new leadership has to build trust all over again. So I built trust as a PI with some of these individuals, and when new people came in, I hadn't spent years with them. I didn't know what their objectives were, and so they have to build trust. That means I'm adjusting on the fly, and the rest of us are meeting Utah where they are at. They know that they want to do research engagement. Our job is to help them get there. So if we have to replay the last 5 years of workshops again, maybe that's what we have to do. But these kinds of things happen when you have these multi-organization collaborations, and you have to think about like, how are you going to address it when it happens? Another thing, sustainability. So planning for the next steps, right? We want to make sure that these programs and roles are adopted in the home organizations. If we only stuck with the 5 years of funding and that was it, it would be a complete waste of time from my perspective. I want these roles to be adopted, and this is part of our organizational mission going forward. And I'm doing everything I can to make sure that happens inside of NevadaNet, and I know my colleagues at the RENs are doing the same thing. So there are new regional opportunities that I'm sure will come up as part of our engagement with the scientists, with the institutions, et cetera. And we, again, for sustainability, we need to demonstrate what is the impact to regional science? What are we changing? Are we moving the needle in terms of how our institutions and the faculty members and students work together? And then education and government agency partnerships are kind of the next piece. So I don't want to say too much about that because there's a lot of like dust in the air around how to partner with agencies and what agencies are allowed to do and not allowed to do. But basically, our objective is to work with the science agencies like USGS, DOE, and others on some of these projects at the edge and work on the technology solutions together. So I think, Betsy, I know I went through a lot of slides fast, but I know we want to give a chance for everybody to discuss, and so hopefully I've left some time for that.
Sounds good. Michael, do you want to facilitate? You want me to?
Sure. Should I stop the recording?
Yes, please.